Hi guys, this is Mrs. Ullrey. In this video we're going to talk about mass spec graphs. So spec is actually short for a device called a spectrophotometer. And so it's a way of us actually being able to detect the number and type of isotopes in a sample. So down here on a periodic table square, this is a number called the average atomic mass. Okay, this value represents the average of the percent abundance of each isotope in nature. Each isotope has a different mass number. So they have a different mass number because they have different amounts of neutrons. So how do we know that neutrons even exist? How do we know that there are different isotopes? And we know that because we use this device here called a mass spec or mass spectrometer. And basically what this is a tube that shoots atoms at really high velocities through a magnet. So that's that thing going across here. And the heavier atoms, as they move through this magnetic field, the heavier atoms are going to curve less, and the lighter atoms are going to curve more. Think about it like this. A sports car can corner really easily because it's nice and light and small, whereas like a semi-truck has to take that really wide curve because it's big and massive. And so basically what this device does is it sorts out atoms by their mass. So the heaviest ones would hit the detector over here, where the lightest ones would hit over here. And we get a readout that looks like these graphs over here, which are essentially just reading bar graphs. So what we're going to do is below we have a mass spec graph for the element magnesium. And it says how many isotopes does magnesium have and list them. So if I look down below here, I can see that I have 1, 2, 3 lines. Those are referred to as peaks. And we count the number of peaks to tell us how many isotopes. So because we have 3 peaks or 3 lines, we have 3 isotopes. And the isotopes we have is a mass of 24. So that means we have magnesium-24. We have right here, so this is 24 and that says 26, so that value is 25. So that is magnesium with a mass number of 25. And then here we have another peak at 26, so this is going to be magnesium 26. Okay, and then it says which isotope of magnesium is most abundant. So down here, these are mass numbers, meaning how heavy the atom is. Over here, these are percentages, right? So what percent we have. The higher the bar, the more abundant that atom. So if I take a look, my tallest peak is for mass number 24. That means that magnesium 24 is most abundant. By the way, this is a dash and not a minus. So that's magnesium dash 24. Okay. So then down here, we're going to look at this again. It says how many isotopes does this element have, element X? And I see 1, 2 peaks. So that means it has 2 isotopes. It says which one is least abundant. So this one is talking about least, whereas this one was talking about most. So my least is going to be my shortest peak, and that is a mass number of 6. So the least abundant is going to be isotope with the mass 6. Okay, so isotope dash 6, right? There's the mass right there. Okay, and then it says, what is the identity of the unknown element? So I can see that 92% of the mass of this guy is a mass of 7. So mass of 7. So most of those atoms are going to have a mass of 7 grams. Well, 7 AMU, atomic mass units. On the periodic table, we would see that as grams. Over here, this one, number 6, so we have a few atoms that are slightly less massive that are only 6 AMU, 6 atomic mass units. Okay, so we're going to look on the periodic table, and we're going to look for an average atomic mass that would be somewhere between 7 and 6, so just below 7. And so I'm going to look along here at the bottom, And so if I look, it's definitely not helium because that's a mass of 4. But here I see lithium has a mass of 6.94, which is pretty close to dead even 7, just a little bit below because of having some lighter atoms there. So the identity of this particular isotope is lithium, Li. Okay, so Li is called lithium. All right, so we've got some more work on the back. So if we take a look here, now we're going to actually make a mass spec graph. And the way that we do that is we have mass numbers here. So 204, 6, 7, and 8. So I'm going to come down here and I'm going to number, and I'm going to start with 204, 205, 206, 207, 208. So I want to make sure there's even spacing, so I'm representing all of those. And then over here I have relative abundance. So what I'm going to do is I'm going to draw peaks to represent. So all I'm doing is making a bar graph, okay? And the bars represent the percents. So if I take a look, I've got isotope 204, so mass 204, and there's only 1%, so that's really not that much. So we'd put the bar roughly there, okay? Now, we don't have anything with a mass of 205, so I'm going to skip over that. And then at 206, I have abundance of 25. So I'm going to come up to where 25 would be. So here's 20, that's 30. So 25 would be roughly here. Let me use pink. So 25 would be roughly here, and that's right above my 206. So there's my 25, and shade that in. Okay, now my next one, the abundance is 21, so it would be just a little bit above the 20 line, which would be right here. So I'm going to graph that. At mass 207, and then 52% for mass of 208. So here's 50, so 52 would just be a little bit above it, and I would draw that in there. Okay, so there would be my mass spec graph showing my masses down below on the X and my percents on the Y. All right, so we have 2 interpreting questions right here, practice 1 and 2. I would like you to pause the video. When you're done with the problems, unpause the video and check your work. Okay, so let's go over the answers now that you had a chance to practice these on your own. If you didn't, stop the video right now and try again. Okay, so let's look at this. It says, how many isotopes do we have? We can see 1, 2, 3, and then there's actually a little line right here. You can see the number above it to tell us that there's one there. So we have 4 isotopes. Which one is most abundant? So the tallest one, that is isotope number 32. Okay, and then it says, what is the identity? So almost all of the mass is 32, so I'm going to look for an element that has a mass roughly of 32. And if I look here, that is definitely going to be my sulfur. So sulfur is 32.06, which makes sense because we have a couple of isotopes that are just a little heavier than 32. So that's going to be element S, which is known as sulfur. Okay. Then down below here, it says how many isotopes does boron have? So I can see 1, 2 peaks, so that's 2 isotopes. Which one is least abundant? It's going to be our shortest one right here. So that is going to be boron dash 10 and shortest peak. That's how we know that that is least. So because B/C is because, so boron 10 because shortest peak. All right, guys, that's it for these.